University, Government College, Chemba, Himachal Pradesh, India. His presentation title is an overview to the industrial water purification by semiconductor-based photocatalysis challenges
Uh, a very good afternoon and a very good evening to all of you from India. Am I audible to all of you?
Yeah, yes, please.
Yeah, thank you very much for confirmation. My name is Dr. Suneel Kumar and I'm from district Chamba, Himachal Pradesh, India. So now I will start sharing my screen. I hope my slides are visible to all of you.
No, not visible. Can you please try again?
Not yet.
Are you facing some problem?
Yeah, I'm trying to share my screen.
Yeah, we can see your screen now. No.
Yes, yeah.
Okay.
Yeah, so my screen is visible, right?
Yeah,
Yeah.
right. Okay.
Yeah, thank you. Thank you very much. So today, first of all, a big thank you very much to this host institution, the grassroots institution, for providing me opportunity to present my research work. So basically, this is in this slides. I will give an overview to the industrial water purification by semiconductor waste photocatalysis process. So in this, I will be talking about the basic process of this water purification, which comes under this very aspect of environmental remediation, then the basic principle involved, and basically the materials involved for water purification, and then I will end.
Please come close to your mic, please.
Oh, okay. So is it fine now?
Yeah.
Yeah, okay now.
Yeah, and finally, I will end with summary and challenges. So the very first one is the very basic thing. What is this process of the photocatalysis? Photocatalysis is basically this acceleration of a reaction in the presence of catalyst and light, as its name suggests, photo. So the presence of light is mandatory for this reaction. So this basic process of photocatalysis is being used for environmental remediation, means a pollutant removal. Let's see what happened here with the photocatalyst. This is in this one figure which you can see on my screen. This is one basic figure of photocatalyst material which we can synthesize in the laboratory. So this basic photocatalyst material is generally a semiconductor material in most of the cases, which is having this CB and BB, means conduction band and the valence band. When such materials, synthesized material, are subjected to the light, it may be the natural sunlight, it may be some light from some artificial light source. When this material is subjected to the light, is absorb the energy, basically the photon energy, and the generation of electron and hole take place. These photo-generated charges, means electron and the hole, then migrate to its catalyst surface, and this is followed by in situ generation of very active radical like hydroxide radical, as we can see on the see on the surface of the catalyst. Basically, this will come from the water which will be there in the reaction medium, as well as the superoxide radical, which will come from the absorbed oxygen in the reaction medium. These radicals are basically very, very highly reactive species. They can react with some pollutants in the water, like dyes, which are basically organic molecule, and they can initiate the bond breakage of those organic molecule to initiate their removal from the water. So basically, this is how a catalyst material, which could be a semiconductor material, can initiate the water purification by removing the water pollutants. So this is the very important one, the first breakthrough in this field of the photocatalysis that came in 1972. This report had been published in the Nature, as we can see here. So this gave these two scientists, Fujishima and the Honda, they achieved this process of photocatalysis on semiconductor-based material. And first semiconductor used was this very important titanium dioxide. This can be synthesized in the lab as well as also commercially available material. So they use this material and achieved the process of photocatalysis. So basically, after this invention, the scientific community, various research groups, they directed their research studies to study these photocatalyst material, not only titanium dioxide, but some other materials also, and to started exploring their applications. Just like here, they use for water splitting, but they also started using various systems for other applications, mainly this water purification also. But as I mentioned, that the light, the presence of the light, this catalyst is the photocatalyst. This works only in the presence of the light. So the design and development of the material which can absorb the maximum portion of the light is very, very important. This depends on the band gap of the material. So here, various research groups, they always try to develop a material which can absorb the maximum portion of the light, just like visible region, which constitute 43%, and followed by this infrared radius, near infrared region, which constitute 52%. Means if the material which can absorb the maximum portion of the light, which can utilize the maximum portion of the light, that will be the highly efficient material, that will be the highly efficient to remove the pollutants from water. So this is the from one of the report, all these are the semiconductor material which had been explored, and to the till date from so many years, and to the till date also various research groups have working on these material. So few of them which I will be talking about, like titanium dioxide, zinc dioxide, basically because these were the very initial material which was the use, and the beauty of these material is very easily we can synthesize in the lab, easily available from easy material, and there is no toxicity, eco-friendly reactions are there. And along with these semiconductor materials, there are some other materials that can be used for the light, as I mentioned, light absorption. Alone, these semiconductor material cannot utilize the full region. So some other material, particularly as I have mentioned, graphene, this is the basically carbon material, graphitic carbon nitride. They are also very interesting. Along with these semiconductor material, they can absorb the light, they can transport the charges which are generated in the presence of the light. So this is the main feature of the material, like high, as I had mentioned, high surface area, more and more active sites, superior electron mobility. The one of the important feature of this graphene material, this graphene is highly conducting in the nature, and they can transfer the electron. So in addition to the semiconductor, now this carbon material is also one of very important material which has been utilized on the wide scale for the removal of pollutant. So here I would like to discuss one of the very recent report based on this one of photocatalyst material, which was synthesized by using this zinc oxide and graphene. So there are the various reported methods which can be easily employed in the labs to synthesize these semiconductor plus carbon material. So this was utilized, and as this process, this figure suggested the basic, this is the degradation mechanism, how this charge was generated on semiconductor, which is zinc oxide, and easily transported to the graphene as graphene is conducting. So this charge was transported, and these radicals, which we can see, are generated, and this is further is degrading or resulting in the mineralization of TC here. In this case, is one of the pollutant. In addition to this, I would also like to mention one of our group report also, which had been published in 2018. We have also worked on the zinc oxide along with this.
Left.
Yeah.
Thank you.
Yeah. Along with zinc oxide and graphitic carbon nitride, carbon material, and this was utilized in the presence of the sunlight for the removal of the dyes. Basically, I have utilized in this case this for the removal of the dyes. So the basic mechanism is the same, which I discussed earlier in these slides. So this is the overall, and there are so many other reports also which has been focused to the till date on these two materials. So this I would like to convey that these are the very easily available material and very effective material which can be utilized in semiconductor material for the synthesis and can be easily employed for the purification of the water, which is basically coming from the industries, which is having organic molecules like dyes and all. So in the last, I would like to conclude that by harvesting this solar energy for this water purification is very attractive as well as one of the very challenging field. And along with this semiconductor material, some other material like graphene had been turned out to be the most promising material as a catalyst for the removal of the pollutants from the water. The challenges in this field are still involved some structural stability. Suppose sometime if there is a long irradiation of the solar light or some other light, this is very important that material should be very stable for the long irradiation time, as well as sometimes since this methods involve some high temperature treatment. So this has to be some concern they need to be definitely addressed to move on to some facile or easy synthesis methods, as well as a large scale synthesis, which is yet to be established, so that these can be employed not only in the laboratories on the small scale, but on the large scale also to purify the water on large scale. So at the last, I'm again thankful to my host institution, Government Degree College Chamba, as well as Dr. Mahendra Salaria and the Grassroots Institution for providing me opportunity to present this work here. Thank you very much.
Thank you, Dr. Suneel Kumar, for your nice presentation. Our next delegate is Mr. Santosh Kafle, faculty member, Department of Environment, Patan Municipal College of Nepal. His title is An Investigation on the Pollution of Inland Surface Water from Industry, a case study of Monohara River. I request.
Okay. Thank you, Professor Rahman. Thank you, Professor Rahman, for providing me opportunity to present my work, which have been done a couple of years back as a part of fulfillment of Master's degree of Environment Science from Tribhuvan University, Nepal. And of course, thank you, Dr. Hasrat, for continuously keeping in contact with me. So I would like to quickly go through my presentation. Okay, is it visible?
Yes, it is.
Okay. Okay, all of we are
Yes, visible. Just go to
yeah. All of we are aware about the water pollution, and fresh water is very invaluable resource because we cannot drink, we cannot quench our thirst through well or petrol like that. Following the year, water is the most important. Fresh water is most important.
Go to presentation mode.
Okay. Presentation.
On the bottom, right side.
Yes.
There is a presentation mode. You click it. There is a symbol of presentation mode just close to 50%. You see the 50%? On the bottom
yes.
right side.
Bottom on right side is remote control and annotate.
Just go left, 50% you see. 50%.
50%. Difficult to find the 50%.
Okay. Okay.
Okay, at the top, go to slideshow. Click on slideshow.
Or you press F5.
Yeah.
Yes.
Press F5. Hello.
Yes. Okay.
Please
Is
press
it
F5.
fine?
Yes. Done. Done.
Okay. So this is all the background about the industrial pollution. I want to simply skip this. These are the progress of industrial growth in Nepal. This composed of some energy, agriculture, mineral, tourism, and service sector industries. This was the older data. So I want to start from the legislation. The existing legislation covering the pollution of the inland surface water in Nepal is the pioneer document is the Nepal Environment Policy and Action Plan 1993. And recently we have Environment Protection Act as a part of the political reformation. We have new acts and regulation, and the Environmental Protection Act 2019 and Regulation 2020 is the guiding act for the protection of environment and pollution control. The rationale of the study is still then there were the 337 households in Kathmandu Valley, which then depended directly on the fresh inland surface water river for use of water. The study of the water quality is very important in case of the spatial and temporal aspects, and the study of the water pollution basically from the industrial discharge was then very rare, and this is one part of the work as a new research then. The basic objective of the study was basically to analyze the effluent quality of industry, measure to industry, and to study the water quality parameter and the pattern for spatial, means in different locations and in measure 2 seasons, and to assess the water quality of Manohara River and to compare the results parameter value against the legal framework. Many other water quality parameters were also determined, but because of the sampling error, few parameters were dropped. The bacteriological water quality was not collected. So this is the study site. This is the, you can see this here, site 1 is the upstream part of the river, head part of the river. Here is the site 2, where the beverage industry is located. Here is the site 3, where the carpet dyeing industry was located. So basically, the effluent from 2 industries were taken, and one side in site 2, the beverage industry is taken, and on site 3, the carpet dyeing industry was taken. Where the site 1 was basically a non-polluted site of the river, and for 2 seasons, pre-monsoon and monsoon, for April and May, and August and September, the water quality, 27 water quality parameters were analyzed there. And these are the chain of custody procedures followed: sample collection, pre-treatment, on-site determination, sample handling, hauling to the laboratory, and determination of the test. These are the chain of custody procedure followed then. So these are the different sampling methodologies taken. Basically, container use was plastics and glass bottles, and sample size range from the 50 ml to 1000 ml based on the standard methodology. The basic sample were taken were grab and composite sample. So for some samples, immediate site analysis were done. Some are refrigerated, some are preserved from longer longer time. So basically, it takes 15 minutes to 6 months to analyze the sample based on the requirement of standard guidelines. So all the experiments were performed following the standard method for examination of water and wastewater from American Public Health Association. And the another quantitative chemical analysis, Vogel 1996 5th edition was used. So these are the different methodologies applied to find out the parameter value of the pollutants. Basically, the gravimetric, tritmetric, and colorimetric methods were applied. For biological oxygen demand, 5D BOD method. For chromium diphenyl carbazide method, iron was determined by phenanthrolene method. And standard titration method were used for the determination of calcium, magnesium, and total hardness. And physical appearance were determined by the expert judgment and sensory perceptions. And pH was determined by using the pH meter. I want to skip this slide. So I want to go to the results and discussion. I think rather than this text, we will have a clear picture from graph. These are the data base obtained for the 27 parameters for April, May, August, and September. So I want to skip this data. So this is the result of the study. So for temperature, in site 1, the temperature was found between 20 to 30 degrees, and it was found slightly elevated for effluence of site 2nd, where the temperature range was found between 30 to 40 degrees, while for the third site, the temperature was found highly elevated for the effluent sample because the carpet dyeing industry used the steam vapor to dye the wool. But as soon the effluent mix with the mixing point at the river and progress towards the downstream, it was found that the temperature is recovered to towards the normal condition. The temperature value is dropped as the pollutant get diluted as it moves to downstream area. So this is the case of the pH. We can see that the pH for site 2nd, which is the beverage industry, was found slightly higher. Might be because the beverage are formed at the higher pH, while the pH for the site 3rd and the downstream was not recognizable, or a different pH were observed. Similar with the pH, the conductivity was also found higher for the influence of the beverage industry for both the pre-monsoon and monsoon season, and conductivity was found a bit higher for the influence of carpet dyeing as well. But as the river progressed downward, it was found that these parameter value were dropped. So it can be said that that there are immediate impacts of the influence on the river water quality. So similar is the case with the total suspended solid. We can see that in both the effluence samples from the beverage industry and the carpet dyeing industries, the total suspended solid content was found higher. Similarly is the case with the total dissolved solids and the total solids. So this is the picture of the dissolved oxygen content. The dissolved oxygen was found between 6 to 7 milligram per liter at the site first, while it was dropped to 3 to 4 milligram per liter for the influence of the carpet drying. And following the influence after following the mixing point, the dissolved oxygen again found raised, while the dissolved oxygen content of the effluents from the carpet dyeing was found very low, almost zero. It might be because of the heated steam. So beverage, as per correlation to the pH, or the pH value suggests, the alkalinity was also found towards the higher side for the effects of the beverage industry. Similar was the case with the chloride and nitrite content. Nitrite content was not observed in the effluent samples of the carpet dyeing industries. And similar is the case with the nitrate. Slightly elevated concentration of nitrate were observed in the effluents of the beverage industry, while at the immediate upstream from the mixing point of effluents and the river, the value was found between 0 to 1 milligram per liter.
Conclusion, please.
Okay, similar was the case with the phosphate. Here we can see the progressive increase of ammonia content in the river as it moves to downwards. It might be because of the influence of the other waste, including the sewage discharged into the inland surface water, beside the impact of the industry. So this is the figure of the calcium, magnesium, and the total hardness. So the iron was also found higher in the influence of the beverage industries, while the parameter value dropped as the river moved downstream. So the chromium content was found higher in the influence of the carpet dyeing industries, because these carpet dye are used heavy metals, including chromium and cadmium and other heavy metals. So this is the case of the biological oxygen demand. Both biological oxygen demand are higher, found higher.
Please go to your conclusion.
Okay, here is the conclusion. Both the industries were found, effluents from both the industries were found polluting. Especially in dry season, the effluents were found more polluting. At the site, many water quality parameters, especially in site water, was found within the WHO standard. And beside industrial effluents, it was observed that it gets polluted through other sources as well. It was found that 100-meter stretch of the mixing point and downstream is not enough to disperse the pollutants. And these are the few recommendations to government for keeping vigilance on the polluting industries, taxes, and subsidies to be provided, including the recommendation for the further study and the discharge of the water temperature as well. So these were the acknowledgement to the supervisor, my department chief, my lecturer, and of course my friends and family member. And finally, I would like to acknowledge the grassroots institutes and the expert team of this session, including this whole undertakings. Thank you so much. Here I stop my presentation.
Thank you. Thank you very much, Santosh, for your nice presentation. Today is very long day. Our last presenter,